Alright, so we started out by looking at these graphically, and so I'm going to take a look at the three graphs. When you graph something, if you have both going up, we got the limit as x approaches 3 of f of x here to equal infinity. And of course, if we went down, the limit as x approaches 3 of f of x equals negative infinity. And finally, if they go in either direction, like that, or it could go like this, the limit as x approaches 3 of f of x still does not exist. So if we did the limit as x approaches 2 of x over x minus 2, and we get 2 over 0, we know we have a vertical asymptote. So when I plug in 1.9, the top part's going to be positive, and the bottom part's going to be negative, which means that this goes from negative infinity when we come in from the left. When we come in from the right, and I try 2.1, we get a positive over positive, which equals positive infinity. If we try another one, like the limit as x approaches negative 2 of x over x plus 2 squared, the bottom is 0 and the top is negative 2, so once again we get our asymptote. But in this case we know that the bottom is always positive because when you square it, unless it's 0, so if it's just to the left or just to the right of negative 2, the bottom is going to be positive, and the top is always negative because whether I put in negative 1.9 or negative 2.1, it turns out to be negative. So we got a negative over a positive, so my limit will be towards negative infinity. So I should have written does not exist up here. And then for this second example, negative infinity. In the next example, we're looking for vertical asymptotes. And when we're looking for vertical asymptotes, what we want to do is we want to find out where the bottom is equal to 0. So in this problem, when I factor, I get x minus 2 times x minus 1, and we have a 3 on top. So when x equals 2 or x equals 1, we have a 0 on the bottom, and because neither one of them cancels out, we're left with x equals 2 and x equals 1. If I did this with the tangent of x, which means we have the sine of x over the cosine of x, nothing cancels, and I'm looking for when the cosine of x is equal to 0. Well, the cosine of x is equal to 0, and it's anything with pi over 2. And so there are infinitely many asymptotes for that particular problem. Of course, if we have f of x equals x squared minus 3x plus 2 over x squared minus 1, and then I factor x minus 2 times x minus 1 for the top, because the multiplied up to be 2 and add up to be negative 3, and x plus 1 and x minus 1 for the bottom. Even though the x minus 1s are on the bottom, then if they cancel, it's not going to be an asymptote, so the only asymptote here will be when you set x plus 1 equal to 0, which means you get x equals negative 1. Alright, so for the one side limit, we're definitely going to get an answer of either negative infinity or positive infinity. So when I plug in 7 over 0, I know it's an asymptote, so now I know it's going to be positive infinity or negative infinity. So when I plug in the 5, I want to plug in something less than 5, so I'm going to plug in 4.9. And so when I get really close, I get 6.9 over, that should be a 5, negative 0.1, which is a positive over negative, which means we're going to go to negative infinity. One more. This is what happens when we have 2 plus. And what I'm going to do here is, because we have this 2 plus, I'm going to change this into the limit as x approaches 3 from the right of 2 plus the limit as x approaches 3 to the right of 5 over x minus 3. And because we get 5 over 0, I know that this is going to go from either positive infinity or negative infinity. And so when I get 2 plus, positive infinity, or negative infinity, really the 2 doesn't have much effect. So when I plug in 3 to the right, that would be 5 over, let's see, 3.1 minus 3 would be 0.1, so we got a positive over positive. So we wind up with 2 plus, basically infinity, but since there's no such thing as infinity plus 2, since infinity is unbounded, we get the answer of infinity.